So this is the agenda for today's webinar. We'll be mainly looking at what are really the components of the data pipeline, how does it work traditionally, and what changed with the big data. And then we'll directly go on the AWS Cloud and how the cloud helps us answer the questions of why, what, and how we could achieve this on AWS. One of the main aspects of today's webinar is to go into some of the patterns of big data processing, mainly stream processing and batch processing. But before diving in there, we would instead take a case study and look at that case study by designing solutions on streaming and batch processing. But then dive into looking at some of the design considerations for general pipeline design, right? So essentially, this is how the data pipeline looks at the high level, right? When you look at any kind of data transformation, you essentially have a source data and a target data, right? That's what the transformation is, and that's what typically happens anywhere in any kind of computation. You have a source and you have a target, and all of the processing that goes through is transforming the data into different you can say a schema or different kind of format that the stakeholder demand, right? So big data or a data pipeline is no exception. You have a source data. There are different high-level components that we can talk about, through which the data moves, and finally you have a target where you consume your target data. So you could have stakeholders, your data analysts, data engineers looking at it through different portals, but essentially you are sending this data through the pipeline that goes to these stages, which is mainly ingestion, in which you decide how you put the data in the format that you require, and then it goes into processing, where most of your business logic, which is very very pertinent to your use cases, processes the data and gets it into a destination, which is could be multiple specific tables in the form of SQL or NoSQL or whatever your use case demands, right? And finally, you have the target audience to actually consume the data. So if we go a little into the aspect of a particular pattern that is very prevalent before the big data came in, is the ETL, right? Which is extract, transform, and load. So if you see, it's again based on the similar components that we saw earlier. We have a source data, then we have an ingestion, and the source data could be coming in the form of CSV, it could be coming in the form of text files, it could be your operation systems, your transactional or OLTP systems that is feeding the data. The ingestion stage is really where you have some of your code that would load the data that you want in a specific format in the staging area just to be consumed. So this staging area could be your temporary tables or any of the landing zones where the data goes, right? And some part of computer storage would be utilized to put that data into that format. Then you have your main component of processing, where the transformation or the ETL part happens, right? So this is where the processing would run your ETL code. This could be your custom SQL scripts, which would be a large set of SQL functions which are already written, or that data team writes them. It could be your Python or a specific language specific code, right, that churns to the data and produces the views that are required. Finally, the processing stage puts this data into a data warehouse, and there could be multiple concepts that come along with the data warehouse. There could be term marks, there could be various tables, or there could be dimensions or facts. It depends on the modeling that is required by the use case. But essentially, in your destination, you could have multiple warehouses or analytics related views created, and that's where your data goes and sits, right? And then it's made available to your target. So this is how traditionally the ETL pipeline worked, and this is a very very we can say very defined pattern that the tables and modeling was very relational as well as schema driven, right? And it adhered to many of the principles of data warehousing, right? However, I'll go to the next slide. And so, however, what changed with the big data is that these are called the three big V's of the big data, right? The volume, velocity, and variety. So essentially, the same pipeline, when it's bombarded with a large volume of data, with a large velocity and variety, it could not keep up with the traditional flow of processing. And this just not included the pattern and the flow, also the technology that were used to process this data through, right? So if you see in this pipeline, the amount of volume with which the data got ingested increased exponentially. The velocity or the change rate with which data came also increased, and along with the variety, right? Because traditionally people would have a very focused use cases which are very relevant to their internal schemas and internal structures. However, when businesses open and with the digital transformation, the things there were too many external systems trying to get into this. Right, there could be a feed from Facebook, Twitter, or many of the other click streams coming into this, and the schema and the variety of data could not be controlled at this scale. Right, so that's when we at this point we start looking at how how all of these technologies or the technologies for the big data particularly can be used to solve these problems, and how cloud helps us to solve this. So before jumping to cloud, let's take a look at what are the technologies that we typically have available for processing this amount of data, right? So I've listed some of the famous technologies which are open source tools, but there are also proprietary tools available to support this. In this case, I have listed multiple technologies. Mainly, these are centered around the Apache ecosystem, but at the same time, some of these are projects which are worked by big companies like Google, Facebook, or Netflix, or many of the giants, which really tried to solve this problem early on, right? Where they had to solve this problem of big data, and they created this technology and then outsourced to the open source world, right? And then so if you look at this, now that we are in the big data world, the amount of technologies and the architecture that needs to be built around is very complex, because these are open source technologies. You need to have the kind of expertise in house or build that expertise to consume this. And on top of that, these are inherently distributed systems, meaning that you would have to make sure that these systems work in tandem and is a good set of monitoring by building it by own hand. It's very difficult.
Rahul, you're not audible. You're breaking.
And it takes and there is all just give me is it, are you able to hear me now? So,
yes, it's better now.
Yeah.
So maybe you can just quickly go over the slide and then you can go to the next.
Yeah. Right. So monitoring, orchestrating, and compliance along with the patch management is again a challenge if you have to build all of these technologies together to solve the big data problem, right? So why big data on AWS? So when we talk specifically about AWS Cloud, and again, this is not an introduction to the AWS Cloud, but AWS out of box provides a lot of scaling, orchestration, or for that matter, any cloud provides all of these technologies out of box, which are not necessarily pertinent to the big data, but they are supporting ecosystem that is required for you to maintain your applications at a large scale in a distributed way, right? And this robust ecosystem, along with by combining a lot of famous framework like Spark, Hadoop, Presto, and some of these things listed on the right, in a very deliverable stack through their EMR technology, is a very strong point where AWS succeeds in providing these technologies. There are managed services supported for streaming. There are managed services for NoSQL and then Mcache and related things. Then there are services for streaming, caching, and querying. So all of this essentially helps us to build faster, build more reliable applications on the AWS Cloud with these big data pipelines, right? And on top of that, there are obvious benefits of having different tiers of storage, compute, and network available on AWS, which helps us. In addition to this, AWS does have their own innovation in terms of having very what you can say, very purpose-specific databases like Redshift, which are massively parallel processing databases. If we have that kind of scale of petabytes or terabytes to support querying at a very performant level, then those options are supported as well. So let's try to put these technologies in perspective and how they are segregated. So if you look at these components, I've listed down the components on the left hand side at the high level. So there are orchestration, there is big data storage, then there are query engines, there are streaming services, databases, and big data processing. Right. Some of the main important components here are the big data storage, the query engines, streaming services, and the processing. So specifically in the processing, specifically in AWS Glue, we have AWS Glue along with AWS Glue workflows that allows us to write Spark jobs as well as combine multiple language-specific jobs in the workflow. And then we have AWS EMR, which where we saw a large number of technologies which are combined, which allows us to run different clusters which are transient or could be fixed, right? So most of the data processing that happens at the large level, where you need to spin up multiple number of such clusters or compute dynamically, is where the EMR and Glue help, right? There are purpose-built databases like Redshift. Then there are databases like TimeStream, Neptune, which are specific to your use cases like graph storage or time series analysis. There are streaming services out of box like AWS Kinesis, which supports multiple suite of services like data streams, data firehouse, and stream analytics. And then if you already have the expertise into Kafka, there is managed streaming for Kafka as well, right? And all of this is mainly focuses on storage and compute of the data, but there are also technologies to query this and make it available to your stakeholders. There is AWS Athena, which helps to act as a query engine, and there could be multiple backends that you can define. It could be as simple as S3, or it could be a configurable database driver for your HDBC. So you can essentially pull out data from various sources and still be able to write your NCSQL on top of it, making it very good candidate for all of the data analysts, right? Along with that, there is Quick Insight for business intelligence that works on top of Athena and other big data technologies. In terms of the orchestration and pipeline, we have AWS Data Pipeline, which helps to write the abstract data pipeline by combining multiple AWS services. Then there are service-specific workflows like AWS Glue workflows. So essentially, all of this helps you to deliver a good data pipeline based on your use cases. Now, the purpose of this webinar would be talking about mainly two patterns, which is stream processing and batch processing. So if you see, this is how at the high level the stream processing works, right? The basic idea is that you have a continuous set of data coming from various sources, and you need to have stream processing worked on that. Now, traditionally, also these things is supported by typically, having certain set of APIs that would just record your incoming events and put them into databases, and then you run some of the queries on the databases. However, there are some advanced use cases like windowing or time series, which does not fit into that notion of collecting the data and running some analysis on it. That's where the stream analytics comes in picture. So you could have a certain set of events continuously coming on the stream, and you would want to query them based on the specific time, and also be able to specify multiple filter. So think about writing an SQL on top of a stream, right, which is a continuous item data of streams coming into your system. So this is for stream processing. That's one pattern. The second one is which is the batch processing, but again, this is for a large amount of data. So batch processing essentially collects and runs your batch processing workflow at a certain interval or on demand, or based on certain orchestration. Essentially, the data is collected as a number of sources, and then the batch processing would work using the common technology like Apache Spark, mainly here in this regard, and that would generate and transform the data and put it into a data sync. And again, that would be made available to a query engine, right? So these are the main two patterns that we'll be looking at. But before looking at the design and how A4 had designed some of this with our customers, we would take an example case study and then look at how that problem could be solved by in these two patterns. So let's define a problem statement. So essentially, this is a log processing system case study where the data engineers and stakeholders need to have insight into a large amount of data. So essentially, there are multiple internal systems and firewall appliances from which the data is coming. This is a large amount of data, and the data is coming in two formats. One is it's streaming through these devices continuously, and the second part is it would be delivered on a cron basis by a certain exclusive service. What the stakeholders are interested in knowing is two parts. One is the data center security insights, and other is the application insights. The security insights is a critical part where data coming from the end nodes as well as firewall appliances needs to identify a certain pattern into the events, and if such certain pattern is seen, it could be a certain vulnerability, or it could be a certain IPs which is blacklisted, or it could be anything which is configured by the admin for that particular configuration, right? And as long as that is detected, it needs to enable other services in the system to send out the notification, and this should happen as early as possible. And the second part is the application insights. Essentially means that there are multiple applications being deployed on this data center, and they are continuously sending data, and that is aggregated at a certain place. It could be your web server logs, it could be your application logs, it could be some some trends analysis that you want to run on your data. And stakeholders are interested in knowing how to understand this application insights. So the solution that is being proposed here is to define the data pipeline as per the design, and it would be a streaming solution for the data center security insights, and a batch processing solution for the application insights, right? So pipeline one would be a streaming, since the data is coming continuously. These set of technologies would be used. I'll go into them. And the batch processing is essentially a large amount of data coming into a certain S3 bucket, right? So for stream processing, various set of AWS Kinesis suite of technologies are used along with AWS Lambda and DynamoDB to finally realize the insights. And for the batch processing, we'll be using the S3 bucket, mainly work on Apache Spark and AWS Glue, along with Glue Catalog to solve this use case, right? In terms of going to the production, if you're able to get both of this pipeline along with the requirement analysis out in 6 to 8 weeks, right? And we'll now go into looking at the design of this. So the first one is for the streaming. So if you see on the left-hand side, there are different devices, as I initially talked about, and then there could be different appliance OSs, which could be router or firewall appliance OSs, which are configured with a Kinesis agent. What the agent does essentially is monitor a certain directory for changing the logs, and then those logs are streamed to a central streaming service called as Kinesis Firehouse, where the log frames are sent to, right? So the Kinesis Firehouse is what AWS calls the delivery stream, meaning that this delivery stream can be plugged into a different data streams and then further change into like that. What we're doing here is we're also interested in taking the raw events. So what the delivery stream does is it writes all of those raw events to the AWS S3, which is an S3 bucket where all the events are written. And then it also had another fork, the stream analytics, which is a stream analytics service by Kinesis, which allows you to query the data on the stream. Whatever is coming on the stream will be queried. So examples of this would be, let's say you're looking for a vulnerability of a particular RDP 123, right? The data engineers or the, in fact, this is for the data admins who can inject all of the configuration that needs to be passed to this analytics, and they can modify, add, or remove this configuration. The analytics or the driver code can then push this into analytics engine and then query on this incoming data. When such filter is passed, this is then pushed into a different Kinesis stream, Firo stream, right, and which is then passed to a Lambda, which folds this into two parts, right? So at this point, you have all the specific vulnerabilities that you are interested in to filter, and those are passed to a Lambda, which decides to do two things. One is to send the SMS notifications, which will be critical and needs to be sent as soon as possible to IT operations. Or this could be your separate notification service where this is sent. And the second part is you want to store these events for further analysis, right? With all the details, or you can even enrich them with your external existing database. For example, if these are known devices, you can add device IDs or any of the configuration management software that you have already present, having some data coming in, and then that would be made available to the stakeholders or analysts to look at what is the trend for seeing vulnerabilities into the system. So this is the architecture of the pipeline that achieves that. And in terms of scale and cost, these are some of the findings that we have seen here. And I have taken a small sample because for the streaming, the data is coming continuously, and it's not in a fixed site for size for all of the appliances, so it will be coming in stream. But let's say 2 million events for 1 GB of data. The average time from which the event has started from the source till it reaches to this particular analytics is close to 80 to 90 seconds. And the cost for such ingestion for close to 1 GB is approximately $1.4. So this is for ingestion as well as analytics, right? So this is about this streaming design. Now, for the second use case of batch design, we have an external log aggregator service, which is doing nothing but collecting the log files from various systems and doing a periodic dump, let's say after 2 or 3 hours. But the amount of size that the data is dumped is quite long. Let's say 50, 100 to 500 GB of data being dumped at the single dump in 1 or 2 hours, right? So this is the source bucket, source S3 bucket where the data is dumped. And in this pipeline, what is happening is when the data is created or data is dumped, an SQS notification is sent that the data is available already. And then there are supporting orchestration services deployed by this Lambda that trigger a Glue workflow. So essentially, what Glue workflow is nothing but a combination of different Glue scripts which are serially tied together, right? And the main part into this is the Glue Spark job that is responsible for slicing this data and then distributing it into different Spark clusters and doing the processing and transformation. So Spark itself will demand a separate session, but to just touch base on what Spark does is essentially, it essentially logically creates a single view of your data. So let's say you have a 500 GBs of raw text files coming into here, or a CSV file. Let's say you have around 200 columns into the CSV file, right? Which is in the format that you want. Now, what Spark does is creates a logical structure called as data frame on top of this 200 GB, right? And then you essentially look at this as a common single table. So whoever is writing the Spark job, it's a logical structure for it to query, transform, and even write SQL on top of it, or to write it into the destination. You can add number of columns, you can add multiple transformations, you can even run multiple ML transforms on it. But essentially, with the Spark, or especially the specific library that you will be using, it could be Scala or Python, you get a standard view of data as a table, and then you write your code in a very structured format. So looking at a Spark script, it may look like a single, just 50 lines of code, but internally it would be spinning up a cluster of, let's say, 50 or 60 servers, distributing them all of this data, then asking them to run the transformation individually on those small data sets, and then finally syncing that data into a destination in the format that you want. So in this case, we are writing this transform data to an S3 bucket into a Parquet format, which is a columnar and binary optimized format. Since the text files that we are getting from the S3 bucket, source S3 bucket, are really into unstructured format, the Spark job helps to at the last scale slice and as well as detect the schema out of the properties that we are interested in, and then finally put this into a destination into Parquet format. This destination is again supported by AWS Glue's data catalog, meaning that you would be able to view what kind of schema is present into this. And since you're able to know the schema, this would be again very well by a service called Athena, which is AWS implementation of the AWS Apache Presto that supports querying on this data set, right? So essentially, once the workflow runs, once the transformations happen, there is a post workflow script that runs and triggers a Lambda service, which essentially allows and calls Athena to process this data and populate intermediate tables, which are some of the use cases that the stakeholders are interested in. In this case, it could be the app trains, or it could be the resources that the applications are using, right? And this would be then populated and available in AWS catalog. In terms of the scale and the cost, I've taken an example of 50 GB, but this can be again made parallel to run into multiple large amount of patches. So for 50 GB, the processing time, the base processing time is around 210 seconds, and the cost is just $1, right? And this configuration, this is subject to the configuration that is used along with the transformation that we are doing. So if you have a complex transformation, or if you have a specific joins, or if you're gathering data from different sources, if you are creating data frames from 2 different sources and joining them, doing some more complex joins and writing it back, then both the processing time will change, and changing the processing time will also incur the cost. One very good thing about the Glue is that they are charging you by a minute, and so how much time or how much complexity that you can reduce in the job, you are automatically getting gained on your cost, right? Your costs go down as your transformations are easier and less complex. So yeah, so some of the design considerations for building this, right? So it is really what are the SLAs and SLOs in this system. As I said, there is in this the service objectives. You would want to batch processing be ready, right? It's important to understand the data change rate and for batch and streaming both, and that the data streams or the fire hose have certain limitations in terms of how much data can be throughput in, and how much data it can handle, and in which case you need to scale out. In case of batch is also important because you don't want to keep on running the workflows of batch again and again. You may be better off writing just a simple schedule that runs maybe after 2 or 3 hours, right? And then I mean, this is the consideration for both of them as to how do you make sure that you are not processing your data or you don't have duplicates into your transform data, right? How do you handle if there are any errors, and how do you make sure that you are not reprocessing it, the same data, so that analytics is not impacted. It's also important to handle failures. Failing fast is the best route, and then notifying through different mechanisms that AWS provides out of box. There are certain basic and advanced monitoring systems that can be put with CloudWatch alarms and certain set of AWS services that should be utilized. And then in terms of the security for your data, I mean, who can access your data? I mean, even keeping in the AWS IAM roles in this space, in the multi-user environment, who has access to your data and how to configure that? That's another important consideration. So yeah, with that, I think I would open the stage for the Q&A.
So yeah, Rahul, we have two questions from Indrajit. So the first question is,
sure.
What is the difference between destination and target?
Right. So your target is essentially how you have your data output, but your destination, I mean, in terms of the block diagram, your destination is where your analytics views would reside, right? Your target data would be something that would be consumed by your analysts or data engineers who are interested into actually querying the data or looking at the dashboard.
Right. So we have another question from Indrajit. How PG-SQL is different from PF-SQL?
Yeah, I'm not very sure what PF-SQL is. If it's some variant of SQL, then to probably check out. But yeah, PG-SQL is yeah. So it's I mean, the PG-SQL would be of course the Postgres SQL. The PL-SQL, I'm not sure I fully understand.
Okay, so we have another question from Sachin. How do we use stream processing and batch processing together? If yes, then can we integrate AWS with Hadoop and Spark? And also whether stream processing is better or batch processing is better.
Right. So yeah. So the answer is yes. You can use them. You can combine them. The stream as well as processing. There are a couple of ways that this can be done. Either if you are using the batch processing, and if you want to use some of Spark streaming part to do that, you can utilize EMR clusters that would help you to do the stream processing with Spark, and even AWS Glue supports stream processing. However, the difference between the Spark and something like Apache Flink, which is a purely stream processing thing, is the Spark does not really do stream processing. What they do is they micro patch the data and put into stream, and then they essentially do the stream processing. So in terms of the pure stream processing, this is not a pure stream processing. So if you want to do that, you might want to look at Apache Flink that would be available through EMR, or you can also write your own application through AWS Kinesis and support Python recently, but I think by default it supports Scala. and write that. In terms of combining both of them in a pipeline is achievable, because both of these pipelines or both of these applications will be creating a certain set of results set in the AWS, right? And then you can trigger on your further workflows to process the data that is created independently by these two pipelines, and then work on that data and process that data.
Okay. So we have another question from Rahil. What will be the stepwise procedure to become AWS engineer if you are a non-IT engineer, non-IT guy, and is completely fresher in the field?
Right. Yeah, so I think it's important to understand both aspects. One is the cloud, and one is the pure big data technology sets, right? So what I would advise is look at a different Apache set of technologies for big data, and then parallel focus on how you can improve your cloud knowledge, specifically if you are looking at AWS, so that you can come at a midpoint to utilize both of these to form new solutions.
Right. Thank you, Rahul. Do we have any other questions?